Welcome to AsE Foodies. This is episode 1.
Good afternoon everyone and welcome to the Spicy Noodles Challenge, Aerospace Engineering Edition. So basically today, we'll be talking about the RP1 or the Refined Petroleum 1 fuel. But of course, before we formally start our challenge, I would like to introduce to you our special guest for today's video. He is the current Lipad EVP and it is an honor to have you, Engineer Ramon Gregorio.
Thank you for the invitation and I'm looking forward.
Ano masasabi niyo po sa food natin for today's video?
Bagay na bagay siya for combustion engineering.
Wow, combustion engineering guys. So, Engineer Ramon, can you please elaborate what is the fuel that we will be talking about today?
Okay, so our fuel for today that we'll be talking about is RP1 or Rocket Propellant 1. It is a long-established hydrocarbon fuel that continues to be widely used since its first development in the 1950s. RP1 is produced from a narrow range of kerosene fraction that is further processed to reduce unsaturated compounds and also sulfur-containing hydrocarbons. Although having a lower specific impulse than liquid hydrogen, which is commonly used in rockets, RP1 is cheaper, stable at room temperature, and far less of an explosion hazard and far denser. This means RP1 is significantly more powerful than LH2 by volume.
Yeah, so thank you so much for that very brief introduction, Engineer. So, Engineer Ramon, are you ready for this challenge?
Ready!
Okay, so the first challenge would be the Chili Pancit Canton. So, in every question, Engineer, you would have one serving of the noodles.
Yes.
Okay, ready now? Walang energy again. Ready ka na ba?
Sure. Ready.
That's good. So, first question. When it comes to the physics of ignition, why is it important to understand the activation energy?
Okay, first, I have to have a serve.
Serving?
Sino nagluto nito?
Parang naparami yung
Sino nagluto
engineer. Sino to nagluto? Come to the camera. Hindi kayo makita. Okay, shy tayo. Mga chef, parang mga ngongo. Kasi
So, for the question, why is it important to understand activation energy? Activation energy can also be described as the minimum amount of energy needed to activate or energize molecules or atoms so that they can undergo chemical reaction or transformation. Chemical reactions also need energy to be activated. They require a certain amount of energy just to get started. This energy is called activation energy. For example, if you struck a match, you're providing the activation energy for the combustion process to happen.
Okay, so thank you so much, Engineer Ramon, no? Habang tumatagal tayo dito, Engineer, the spicier the noodles will get. So, I hope no that Engineer will survive this challenge. Okay, so for our second part of this challenge, before we start with the question, we should eat first. So, our second noodles would be the extra hot chili from Pancit Canton.
From Lucky
Me. Baka naman. So, for our second question, can you elaborate on the reaction rates and oxidation mechanics of this fuel?
So RP1, when RP1 is ignited with oxygen in the combustion chamber, the alkynes undergo combustion to provide the carbon dioxide gas and water vapor. The reaction is highly exothermic, giving off a large amount of energy to heat up and expand the gases. As the hot gases rush out of the combustion chamber, they exact an equal but opposite force. This thrusts the rocket into orbit, escaping the clutch of Earth's gravity. So, to answer your question about the reaction rate actually is, for a given chemical reaction, is the measure of the change in the concentration of the reactants or the change in the concentration of the products per unit time. The speed of a chemical reaction may be defined as such. For the reaction from A plus B and producing to a product of C, the rate can be expressed as such. The reaction rate is dependent on the concentration of the reactants as well as the rate of constant However, there are also factors that can influence the rate of reaction. And these factors are included are the temperature and the catalyst.
So engineer, for our first follow-up question for the second question, what is the oxidation mechanism? So before answering, again, please take 1 serving of these noodles.
As we all know, for engines such as rocket engines, there are oxidizers as well that combines with the fuel, and in our case, the RP1 fuel. So in the mechanisms of the oxidation and the reduced reactions or redox reactions involve the overall transfer of the electrons from one species to another species. The chemical species being oxidized loses electrons to the chemical species being reduced. And there are several well-known oxidation mechanisms, and to name the few, we have 5. First will be the ester mechanisms, next the hydride transfer mechanism, and the third, the hydrogen atom abstraction mechanism, and fourth, the electron abstraction mechanisms, and lastly, the displacement mechanisms. So those are some examples of how the oxidation mechanisms works.
Okay, so thank you so much, Engineer, for answering and for surviving our second challenge. So far, Engineer, how was your experience?
It's still tolerable and I can still feel my taste buds.
So tingnan natin sa third and fourth kung ma-feel pa ni Engineer ang kanyang taste buds. So that's it for our second question. Okay, so we are now on our third question for our third challenge, which will be the ×1 samgyang noodles. So, Engineer, medyo challenging na ito.
Yeah.
Are you ready?
It's a famous noodles, pero I think kakayanin natin.
Kakayanin, okay.
Because
So,
in aerospace, there is no limits.
To make this more challenging, sasali na daw ang host to eat this 1 serving before ako mag-ask the question. So, I'll help you, Engineer.
A follow-up question din, host.
Hindi, sa first question. Okay, sige. So, for our third question, now that we have learned about the activation energy, the reaction rates, and oxidation mechanisms, how about the thermodynamics behind it? Kain mo na kami, guys.
To answer the question of the thermodynamics behind it, first we must discuss the thermodynamics. First we must discuss what is thermodynamics. Thermodynamics is a branch of physics which deals with the energy and the work of a system. It deals only with the large-scale response of a system which we can observe and measure in the experiments. Small-scale gas interactions can be described as the kinetic theory of gases. The methods complement each other. Some principles are more easily understood in thermodynamics, and some principles are more understood in the kinetic theory of gases.
So, Engineer, parang nahihirapan ka nang magsalita doon, Engineer. Parang medyo may effect na ba siya?
Yes, so nagsisimula ng combustion.
Engineer, itutupad ko yung request mo na for the follow-up question, magkakain din ako.
Sure.
For our first follow-up question, why study chemical thermodynamics? So, kain mo na. Ayan, may mga audience tayo dito, guys. Natatawa sila kay Engineer. Kaya yan.
Okay, so, why do we need to study chemical thermodynamics?
Medyo napapagay. Okay, sige, go na, Engineer.
Thermodynamics revolves around the study of heat. So, heat. Particularly the movement of heat, which is thermo, and the movements, which is the heat and the dynamics. So, thermodynamics. By studying this, we will be able to learn how certain reaction occurs, which will be crucial to the aerospace engineering applications, where conditions are on the extremes unlike down on the ground.
Ayan, so medyo extreme na ba ang condition dito, Engineer?
Papunta na siya sa exciting part.
Papunta pa lang tayo sa exciting part.
For our second follow-up question, why study the kinetic theory of gases?
So, why study the kinetic theory of gas? Kinetics focuses on the rate at which reactions take place and the factors that that affect these chemical reactions. It suggests that the gases are composed of particles that are in motion, and by looking at the factors that may affect chemical reactions.
They ask you how you are, you just have to say that you're fine when you're not really fine.
Parang nalalasanan ni engineer yung ano, heat. Sige, go on.
We are able to understand the control these factors, allowing us to be able to initiate reactions whenever we want and avoid excessive loss and damages.
For the last follow-up question, what is enthalpy? Okay, cheers.
So what is enthalpy? Enthalpy is the thermodynamic quantity equivalent of the total heat content of a system. It is equal to the internal energy of the system plus the product of pressure and volume. If the change in enthalpy is positive, the reaction is endothermic in nature. And a lower enthalpy means it requires less energy. So some of the thermodynamic properties of RP1 are the following, which can be seen on your screen.
Okay, so that's the end of our third round of the challenge. So we have reached the last challenge and the last question for this video. So for our last challenge, we will have the ×2 samya. What is the relationship between laminar flame and the transition from subsonic to supersonic speeds?
So we must define and answer the question, what is flow first? So what is flow? Flow is the fluid mechanics. It's the movement of liquids or gases, as generally referred to as flow. A concept that describes how fluids behave and how they interact with the surrounding environment. For example, water moving through a channel or pipe or over a surface. That's what we call as fluid mechanics. And flow can be either steady or unsteady. So, following that up, what's the definition of a laminar flame? It is defined as the propagation rate of a normal flame front relative to the unburnt mixture. It is an important property for pre-mixed flame as it embodies the fundamental information of diffusivity, reactivity, and exthermicity of the combustible hydrocarbon mixture.
Last follow-up question for this video. Second to the last follow-up question. Okay, so diba, I stand corrected. Why is laminar flame speed important?
Laminar flame speed is the propagation speed of the flame cone under laminar conditions at which the oxidation takes place and is the key factor for determining the sustainability of gas. So laminar flame speed are also practical building blocks for understanding fuel behavior in devices that operates via mixture deflagration. On the practical level, laminar flame speed is related to the burning rate in the combustor, which can affect the combustion efficiency and exhaust emissions. Laminar flames are smooth in appearance. They have what might be referred as smooth flow. Smaller flames are more likely to be laminar since whether flame is laminar or turbulent, it depends on the properties of the fuel vapor as well as the diameter of the fuel source.
That's right. So guys, take note of those properties of the fuel vapor and as well as the diameter of the fuel. So for the million-dollar question, why do we need to transition from subsonic to supersonic?
For the laminar flame, as we know for rockets, we want to produce as much of power as possible to be able to achieve the force required to go to space. For RP1 fuels, this power requirement leads to an increase in temperature, which then increases the speed faster than the speed of sound. At subsonic speeds, deflagration occurs when a flame front propagates by transferring heat and mass to the unburnt air vapor mixture ahead of the front. The combustion wave travels at subsonic speeds to unburned gas immediately ahead of the flame front. Flame speeds range from 1 to 350 meters per second at low speeds. A detonation, on the other hand, occurs when the flame velocity reaches supersonic speeds, which is above 600 meters per second, and generally in the range of 2,000 to 2,500 meters per second. Peak overpressures can be 20 to 100 times the initial pressure, with typical values of 20 bar. Detonation can be initiated by either the use of high explosive charge or from a deflagration wave that accelerates due to the congestion and confinement. So
and there we have it. We have reached the end of this challenge. So thank you so much to you, Engineer Ramon, for accepting the challenge. And we hope that you learned a lot from today's video about the R1 refined petroleum fuel. Stay tuned for more episodes and more challenges with different guests. This has been Sam, signing off. Bye-bye! Wait, huwag ka magsabi ng next.
Yeah. Enthalpy is the thermodynamic quantity of flow in fluid mechanics to an increased temperature, which then increases speed faster than the speed of sound. Grabe po kayo itim ko eh.
Ayoko na yung chicken, distract ako. Ulit.
You're providing the activation energy for its combustion. What's the problem, host?
Sorry.
P1. Pero feeling na ko kay...
Kung lima na po. So, anong oxidation mechanism na? Nissan is known.